No, this is not a computer junkyard. I actually have this stuff sitting here on purpose, because today we're going to talk about computers. I'm Alex. Welcome to the Renaissance Builder. So this video isn't for the people out there that are watching this that already know about computers. If you want to watch, be my guest, but we're not going to go over anything that you don't already know. This video is for those of you who don't know what computers are, or, well, you know what they are, but you don't know what goes on inside of them, and you've never really actually opened one or worked on one. So I'm going to be building a high-end computer soon for the channel, and I thought I would take this opportunity to just go over the basics of what a computer is and what the different components do. So to do that, I collected some, well, honestly, they're scrap computers. They're really not worth a whole lot. So let's start with the outside of the computer. What you see the most, just a box. Now, the thing that's similar between a lot of computers is the case. You're always going to have a back panel, a front panel, I should say most of the time, because there's some pretty crazy ones out there. But you usually have an access panel on one side, a front panel, and a back panel. The front panel often has your power, headphone jack, a microphone jack, and USB ports. The back panel almost always has all your inputs and outputs, called I can't even talk. It's the I/O of the computer, the input-output interface. So that's where you would plug in like your monitor and your keyboard and the things that are not going anywhere. The front panel is for the convenience of plugging USB sticks in and out, maybe mice, depends on your taste. Back panel is for the stuff that's going to stay there. So then there's always the access panel. Now on this computer you can see we already have the access panel off, so you have a general idea, and I can point to this for reference. So, access panel. Right, now you open the computer up, you take a computer and you open her up, and if this is your first time opening up a computer, I really don't recommend opening up a computer that you need, such as one that you're using, or the family computer. I recommend opening up one that is junk, like this, that is not needed or is getting replaced, so that if you break it and you can't put it back together, it doesn't really matter. You still learn something, and nobody's the worse for wear. So when you first open up your computer, the first thing you notice is so many wires and cables. You know, ribbon cables and speakers that are completely useless, and other cables and wires that are attached to things. Quite often, they're all multicolored, and it's a mess. Don't think about all that so much. Yes, it's messy, but there's a system to the madness. So, let's start pulling this thing apart. Now, what I'm going to do is I'm just going to go ahead and take all this stuff out of here. Everything that was in here. And this computer is actually unique in that this is a Dell workstation computer. And when Dell created these workstation computers, they engineered everything that goes into them very specific for this chassis. Everything works together in this chassis. Now I want to start with what I'm going to call the nervous system of the computer. It's the primary piece. It's what everything works through. All the signals go through the nervous system in your body. What tells you that you can touch something and you can feel it. Your brain is what's acknowledging that you're touching something, but the signal has to go from your tips of your fingers back up to your brain. So this, oh great, I snagged her up in there and now it wants to, there we go. And again, that's the case. So this is called the motherboard. Now the motherboard, pretty much every computer has a motherboard. You can see the motherboard in this one. It's the first piece that you really, first large piece that you really notice inside of a computer when you take off that panel, once you get past the wires. The motherboard is essentially the interface. The motherboard is what directs all the signals and where they go and what they need to do. Well, mostly where they go. So on the motherboard is what we really want to focus on. The fact that this is a motherboard sitting right there. I have another motherboard right here. This one's a bit newer, still just as useless, but it's a bit newer. And so there's just different types. This motherboard in this computer is actually extremely unique to Compaq. Compaq used to, in order to cut costs and make their computers cheaper, they used to get their motherboards made for them with already for example, the video processing is built into the motherboard on this. The processor, all that does is just the processing stuff. And then the video card, which on modern computers is often an expansion card or part of the CPU. In these computers, they were put on the motherboard itself because that cut the cost of having to have a whole nother component deal with video processing. So that's unique to that computer. This motherboard is unique to Dell's computer, mostly because Dell wanted their equipment laid out a certain way. They wanted the I/O pointing a certain way. They wanted to be able to plug in the plugs a certain way, because everything engineered in that Dell computer was designed to cut cost and make that station do just exactly what it needed to do for as little money as they could get it to do. Yeah. So when you get into these computers from Dell and Compaq and a few of these others, pre-made manufacturers, you're not going to find standard equipment. You're going to find equipment that's made for that case. So that's what this is. Whereas this is more of a universal motherboard made by MSI. Whereas this is designed to go in many different cases and is designed to have many different kinds of things plugged into it, whether it be video cards or internet cards and the likes. The power connector is standard, so pretty much any off-the-shelf power supply will plug into it. The RAM is standard, so that pretty much any off-the-shelf RAM will plug into it. And the PCI slots are standard. Again, so that pretty much anything you want to plug into it with that format plugs into it. So beyond that, that's the motherboard. Now, the next most important piece that goes into a computer is the CPU. Where did I hide that sucker? Here it is. This is the CPU. Now, this is a very special little piece. Inside this is just the heat spreader. If I could take this off, and there's a tool to take it off, I've never done it. I've seen it done, I've never done it. But this is just a heat spreader. The silicon chip is actually underneath this, and it's probably a quarter the size. That houses all the goody works, all the micro circuitry and there's transistors in there for days. Literally millions of transistors in a little tiny chip, all with the purpose of processing digits, ones and zeros, quite literally. Now the CPU on the computer goes into the CPU socket that's located on the motherboard. In this case, it's this piece right here. Now, I'm going to go into greater detail of exactly how you're supposed to put these things together and the tips and tricks to doing so when I actually build the other computer. Now, I just want you to know generally how it goes together and what these pieces are. So the CPU goes into the CPU socket, and it only goes a certain way. Just sits right in there and latches down. That's the CPU. Now the CPU you could think of as the brain. All the signals from everything else filter up to the CPU, and then the CPU decides what to do with those signals. Next from the CPU, aside from your CPU heatsink, CPUs need heat sinks because there's a lot of stuff going on in that little tiny chip. Like I said, there's thousands and millions of transistors in there switching on and off and using voltages in small spaces. When you use a lot of voltage in small space, you generate heat. So these things get pretty hot. So to deal with that heat, you have the CPU cooler. Oftentimes, that's one of the big things that's noticeable in a computer, that's especially for air cooling, is the CPU cooler. in this case, it's a massive chunk of aluminum. In the case of, and it just literally sits right like that on top of the CPU, and there's a fan that gets funneled to it. That pretty much always has a thermal paste to transfer the heat from the heat spreader efficiently into the CPU cooler. So that's the CPU. The next most important thing we have on the motherboard is the RAM. Now the RAM is your memory, where your brain decides what to do with the signals. Like your brain recognizes that something's happening with your fingertips. It's your RAM that's your short-term memory and decides what you should do about that. It tells you that, oh, that's your skin. It tells you that, oh, maybe that hurts and will stop. So your RAM is like your short-term memory. So that slips into these here slots firmly with a click. And that interfaces through the motherboard with the CPU. The CPU uses the RAM to store the information as it's processing. Believe it or not, the CPU processes one thing at a time. Now that's a very basic way of saying it, but it's essentially what it does. And as it's processing it's one thing at a time, and the things that need to get done build up in the computer, then it's the RAM that it uses to store that information until it needs to access it and process that particular item. It's just a way to not only allow the CPU to do its thing, but also allow the CPU to do its thing at its own pace. The next most important thing on the motherboard. Now we don't have a graphics card in this at this point in this computer, but there would be a graphics card or any other extra card. For example, most motherboards have built-in audio processing. They do that because, well, audio processing is super cheap. And at this point, a motherboard that doesn't have audio processing is either super high-end and focused on a very particular performance, so that the audio is like, eh. However, if you want better audio, then you can get a card that slips into these here expansion slots. And then that tells the motherboard BIOS that, hey, there's a card in here that deals with the audio. From now on, we need to send our audio signals from the CPU over to the audio card for processing instead of the internal audio system. That's what the motherboard does. It decides what does what and where signals go. There's one very important extra thing that's on every motherboard. It's called a BIOS. And I don't know where it is, but it's usually located on a chip. Like, for all I know, this could be the BIOS chip on this motherboard. Probably not, but it could be. Now, the BIOS is what we call a firmware. The BIOS is what actually dictates what happens and how it happens and when it happens on a motherboard. The CPU needs to do its thing. In order for that to happen, the motherboard needs to know what that CPU is. So the BIOS is in charge of recognizing the CPU and setting up all the lanes and the travels of information, highways in there, correctly. The motherboard also needs to know what kind and how much and how fast your RAM is so that it can interface with the CPU properly. The motherboard needs to know what cards are in these expansion slots so that it can filter all the information correctly. And the BIOS is something that, whilst it can be updated, it can't be changed. I mean, it can, but that's a whole nother level of stuff. So that's why it's called firmware. It is necessary. Software operating system like Windows, you don't have to have Windows. You can put Linux on as your operating system. However, if you have an MSI motherboard, then you have to have an MSI BIOS. They work hand in hand, and it will not work without it. Now we move on. We have our CPU, the brains. We have our motherboard, the nervous system. We have our RAM, the memory. Now we need long-term memory. We need something that's going to store all our long-term memories. For example, the fact that this is skin, you know, the nerves, using my fingers again, the fact that it just remembers all the important stuff. like your operating system. In the computer, every time you save something to your computer, that save gets stored on a hard drive. Nowadays, there's solid state hard drives and NVMe hard drives, and there's still spinning disk hard drives. But back when this was a thing, it was really just spinning disk hard drives. I remember building my oil-filled computer like 10 years ago, and the solid state hard drives were becoming a new thing back then. And I remember getting excited about that because you can't put a spinning disk hard drive in oil, but you can put a solid state one in there. So that's what I ended up doing. This is your hard drive. In this computer, your hard drive is located right in here, in a mounting bay. Now, the way a hard drive works is there's a bunch of spinning disks in here, very similar to a CD player. Those disks have information written to them. What is not like a CD player is that information stays on this disk. It does not matter how long this disk sits. If you pick it back up 10 years from now, assuming that it was kept in perfect condition, you know, dry climate and all that kind of stuff, it wasn't dropped and soaked and rained on, assuming this thing was kept in great condition, if it sat on a shelf for 10 years and you plugged it in, it would still have that information on it, because it's recorded on a firm disk that's protected. Now, in order to read the information that's put on it, there's an arm that swings, and it's kind of like a record player. If you ever watch a record player work, the disc spins, and there's an arm that reads it. And that's what happens inside of a hard drive, a spinning disk hard drive. It spins the disks, and then that arm goes to where it needs to go, based on a little memory circuit built into it, goes to where it needs to go to read the memory that it needs to access. The computer, now the reason they don't mount the hard drives firmly to the motherboards is because hard drives, they do go bad. They're a mechanical part. They go bad more often than the motherboards go bad. And they also, you may want to expand your hard drive. You may want to put a bigger one in. So almost every manufacturer of computers makes sure that you are capable of increasing and changing your hard drive. That's why they're not firmly mounted to the motherboard. Instead, they use data cables. This is called a SATA cable. SATA is simply the way it transfers data. So the SATA cable plugs in. It's the format of the cable. And then it plugs into your motherboard. It just provides the bridge of information so that now the information can go to the motherboard and be filtered back up to the processor. In order to power it, this whole arrangement, you have a power supply. That one's name is pretty straightforward. Most power supplies, well, pretty much every power supply does the same thing. Some of them do it in a different way, but power supply is a power supply. It plugs into the motherboard, feeding the powers and grounds that the motherboard needs. Everything from 12 volts to 5 volts to 1.5 volts, any different kind of power that the motherboard needs, the power supply supplies. Now, it also supplies power to your hard drive. In this case, the CPU needs an extra power supply because, well, it needs extra power because our 24-pin connector down at the bottom of the motherboard doesn't have enough room to get all the energy to the CPU that the CPU needs. So they put an extra one up here, and that's what this cable's about. We have power to it. We have our memory, like our long-term memory. We have an interface that brings everything together to talk to the CPU, which is the brains, and the RAM, which is the short-term memory. As it sits right now, this computer would work. Now you want the extras, such as a DVD drive. And again, a DVD drive, similar to a hard drive, needs to transfer data. So it has its own data transfer cable, again, in the SATA format. And that, again, plugs into the motherboard. It's kind of a common thing. Everything plugs into the motherboard because the motherboard is the interface for everything that needs to get to the CPU. Now, you could have other things going on here. You could have a video card. You could have an audio card. You could have an Ethernet card that is better than the built-in motherboard Ethernet. You could have, there's lots of other things that you can plug into the expansion slots. You can plug in different kinds of RAM. You can upgrade your RAM. You can upgrade your CPU to a certain degree. For example, I have a Core, an 8700K, that whilst it'll physically fit on this motherboard is not capable of supporting such a processor. I don't know if it would run just really slowly or if it just wouldn't run at all. I'm going to predict it just wouldn't run at all. So there you go, guys. That's the core functions of a computer. Motherboard, processor, RAM, and everything there. So if you have any other further questions, I mean, feel free to throw a comment and a question in the comments if you have any. But I know this is real basic, and it's not like in-depth information as to what a computer is or how it works. But that wasn't the point. I just wanted you to get familiar with the computer, what's inside a computer. Once you get past the clutter, you can begin to identify each individual component and have a much better idea of what's actually going on in that computer. And if you want to play with it yourself, it's actually not that difficult. So that's it for my story on computers. Hopefully you guys learned something, become maybe a little more comfortable with this, and hopefully now that when we get into building the high-end computer, you actually have a little better idea of what we're all putting into it, because those things are going to be a bit different, and we're going to go into more advanced, how things work and why we do the things we do with the components we do on them. So thank you very much for watching. Again, I hope it helped you. I hope you learned something or at least found it entertaining. I appreciate your attention so far, and I appreciate your views. Go ahead and throw a thumbs up in there. It really helps out the videos a lot if you throw a thumbs up in there, which I really appreciate. And thank you very much. Make sure you're subscribed. Hit that bell icon for future videos. Like I said, building the computer, the high-end computer, as well as everything else we got going on. I keep mentioning it, all the fun projects and all. You don't want to miss it. There's good stuff coming. Thank you very much. You guys have a good night. I'll see you in the next one.
Bye-bye.
Did you boldly go today?